Hello, Math 1050. This is a video for section 5.5, Nonlinear Systems of Equations. So if you recall back to the beginning of this chapter in section 5.1, we were solving systems of equations, and they were all made up of linear equations. In this section, we're going to be doing some linear equations along with some other types of equations. For example, if you take a look at example 1, we have a quadratic equation with a linear equation. Luckily, some of the same strategies that we used in 5.1 will apply also to this one. So if we take a look at these two, let's go ahead and try substitution. I'm going to go and solve for y on this second equation. And we'll get y is equal to -2 minus x. And now I can substitute in -2 minus x into y in the top equation. So let's go ahead and do that. And now we just have one equation with one variable, so we can go ahead and solve for x. Let's go ahead and distribute through the negative. And now I notice that I have a quadratic term and a linear term, so we have to get this equal to 0. And I'll get it into standard form at the same time. And this is factorable. And now we'll set both of those factors equal to 0 and solve. We get -2 and +1. Now, those are just the x values. So now we got to go back and find what the y values are. Luckily, in our equation that we solved for y, y is solved for. So we can just plug in x, the values we got for x in that equation, and we should get y pretty easily. So we'll get y is 0 when x is -2. And when x is 1, we'll get -3. So now we have an x and a y and another x with its associated y. So we can write this as an ordered pair, two ordered pairs. We'll go ahead and write that as -2, 0, and 1, -3. And that is our solution set. So we've got two answers to this system of equations. Okay, so go ahead and pause the video and see if you can do practice A. All right, let's see how you did on practice A. So what I'm going to do is I'm going to go ahead and solve for y on this equation, on the second equation. And it's x plus 4. So now I can replace y in the second equation with x plus 4. And then from there, we're going to need to do some algebra to solve for x. So quite a bit of algebra on this one. Oops. And again, we have a linear term with a quadratic term. So let's go ahead and get it into standard form and equal to 0. And this one is factorable, so we'll go ahead and factor it. And then we'll set both of those factors equal to 0 and solve. And we get two values again for x. We get negative 11/5 and negative 1. So now I can replace those in the x on my equation that I have solved for y. So when x is equal to negative 11/5, we get that y is equal to 9/5. And when x is equal to negative 1, we get y is equal to 3. So now we can write that as two ordered pairs. We can write that as negative 11/5 and 9/5 and negative 1 and 3. So hopefully that's what you got. Let's take a look at example 2. So just like with linear equations, sometimes these ones are set up so that we can use elimination. Let's go ahead and try that. If I add these two equations together, I'm going to get 3x squared plus 0y is equal to 12. So then I can go ahead and solve for x now that I don't have any y's. And we get x is equal to positive 2 and negative 2. Now we can go ahead and plug that into one of the equations to solve for y. I'm going to plug it into the top one. Looks like there's less going on, so it might be a little easier. So instead of x squared, I'm going to plug in 2, so 2 squared plus y squared. And we actually get 0. So when x is 2, y is equal to 0. And let's go ahead and try negative 2. And the math is actually going to be the same on this because 2 squared is the same as negative 2 squared. So we also get 0. So we've got 2 for x, 0 for y, negative 2 for x, 0 for y. Go ahead and pause the video and try practice B. Okay, here we go with practice B. So hopefully you noticed that we can't add up the equations yet because nothing would eliminate if we did. So we have to set them up so that we can do that. So I'm going to multiply the top equation by 5 and going to multiply the bottom equation by 7. That way my y's will match up and I'll be able to add those up and eliminate my y's. So if we do that, we'll have 30x squared plus 35y squared is equal to 890. And the bottom equation, 49x squared minus 35y squared, that's how those are going to get eliminated. It's equal to 1085. So now we'll go ahead and add those up. I get 79x squared is equal to 1975. Now divide by 79. We actually get a nice number, 25. So therefore x is equal to plus or minus 5. Now I can plug that in to find y. I'm going to plug it into the top equation. So when x is equal to -5, we do a little bit of algebra here, and we'll get 7x squared is equal to 28, x squared is equal to 4, and x is equal to plus or minus 2. And then when x is equal to +5, the algebra will actually be the same, because -5 squared will give the same result as +5 squared. So those should have had the same steps, and we get that again. Oh, let's see, I wrote x there. Sorry for that. That should be y on all of those. We found y is equal to plus or minus 2. So y squared. Okay, so for this one as well, we get that y is equal to plus or minus 2. So now we have 4 ordered pairs. When x is -5, y is either -2 or +2, and when when x is +5, y is -2 or y is also +2. So we've got 4 sets of ordered pairs there, or 4 ordered pairs. Hopefully that's what you got. Let's go ahead and take a look at example 3. This one doesn't look like it's, we're going to be able to do elimination with it because we have x times y. So substitution is going to have to be the way to go on this one. I'm going to solve for y on this second equation. So I get y is equal to 45 divided by x. And then I will replace y in the first equation with 45 divided by x. Okay, and now we've just got x's. Let's go ahead and solve for x. Notice how I've got x squared in the denominator. That's not too fun to deal with. So let's get rid of that denominator by multiplying both sides by x squared. So then we'll have 5x to the 4th minus 2025 is equal to 44x squared. Looks like we're going to have to get this equation equal to 0. And in standard form, and believe it or not, this is actually factorable. It's actually factorable. So it factors to 5x squared plus 81 and x squared minus 25. So if you set both of those equal to 0 and solve, you are going to get that x is equal to plus or minus 9I root 5 over 5. That's just by putting negative 81 over 5, the square root of negative 81 over 5 in my calculator, and it will rationalize the denominator, getting that root on top with the I and leaving 5 on the bottom. And then luckily the other one's not as crazy. We get that x is equal to plus or minus 5. Okay, so now we've got to plug all of those in. So let's see here. Plug those in, that second equation where we have y solved for. So y is equal to 45 over, let's do the easy ones first. Let's plug in -5. So then y is equal to -9. And then y is equal to 45 over 5, which will give us +9. And now this one gets kind of gross. We've got y is equal to 45 over, let's do the negative, 9I root 5 over 5. Luckily, your calculators will be able to handle that. So just type that in, and it will tell you that y is equal to 5I root 5. So that's really nice that our calculators can do that. It's not a nice result. And then let's plug in positive 9I root 5. So 45 over positive 9I root 5 over 5. And type that in your calculator. And you get negative 5I root 5, which makes sense. The only difference between those two that we plugged in where it was a negative and a positive, so it makes sense that it's going to be the same number, but one is negative. So we have another set of 4 ordered pairs. So when x is -5, y is -9. When x is +5, y is +9. When x is -9I root 5 over 5, y is 5I root 5. And when x is +9I root 5 over 5, y is -5I root 5. So it looks very strange, those last two solutions. Oops. But those are complex solutions, so they've got i's with them. Okay, let's take a look at example 4. Find two numbers whose sum is 15 and whose product is 26. So if we read that again and try to make sense of it, two numbers, let's name them x and y. Their sum would be their addition. That's equal to 15. And their product, that would be multiplication, is equal to 26. Now, if you're familiar with numbers and multiplication, you could probably just figure this out. But if you want to know how they want us to do it, we can solve for y here. And then we can replace that into the y in the top equation. So we have x plus 26 over x is equal to 15. Kind of like the last problem, we've got something in our denominator. Let's get rid of that by multiplying both sides by x. So we'll get x squared plus 26 is equal to 15x. Get it into standard form. And this is factorable. So the factors of 26 that add up to -15 are -13 and -2. And set those equal to 0 and solve, and you get x is equal to 13 and +2. Notice how that's actually like the x, like both of those are x's, but when x is 13, y would be equal to 2. And when x is 2, y would be equal to 13. So it's like the same number. So the answer for the two numbers would be 2 and 13. Okay, let's go ahead and take a look at the last problem, example 5. It says the longest side of a right triangle is 25 meters in length One of the other sides is 5 meters longer than the shortest side. Find the lengths of the two shorter sides. Okay, let's go ahead and let's draw a diagram here. So it says the longest side of a right triangle is 25 meters. And then we got to break this down. It says one of the other sides is 5 meters longer than the shortest side. So if the shortest side is x, then the other side is x plus 5. Now to solve for that, we got to come up with a relationship that we know about right triangles. And you guessed it, that is the Pythagorean theorem. So let's go ahead and put how our triangle is labeled into the Pythagorean theorem. So we'll have x plus 5 squared plus x squared is equal to 25 squared. And then we are off to the races to solve for x. So we'll go ahead and combine like terms on the left side. And how about we get it equal to 0 as well? You could try to factor or do the quadratic formula from here, but I noticed that every coefficient is even, so I can divide everything by 2, make things a little easier. And so we'll get x squared plus 5x minus 300 is equal to 0. And believe it or not, that is factorable. Factors 2, x plus 20 times x minus 15 is equal to 0. You could also just do the quadratic formula. You should get negative 20 and positive 15. So that would be the possible lengths of the short leg. However, negative 20 does not make much sense for a length of a side of a triangle. So we can kind of throw that out. So 15 would have to be the length of the short leg. We were also asked to find the length of the other leg, the two shorter sides. And to get that other one, we know it's 5 meters longer. So 5 more than 15 is 20. So we've got 15 meters and 20 meters. And that would be the answer for example 5.